Well, hello geometry. Welcome to another week. This week, unlike our parallel line angle relationships, we're talking about triangle angle relationships. Now, our parallel line angle relationships will still make an appearance. So like I said last week, if you do not know those vocabulary words yet, make the time to get them committed to memory, because we're going to be adding some new words this week, as well as applying those previous ones in some new diagrams and some new looks. The first triangle angle relationship we're going to be looking at today is a fancy way of saying something that you might have already experienced before, and it is called the triangle sum theorem. Now, the triangle sum theorem is really just a fancy way of saying that all three angles in a triangle add up to 180 degrees. The triangle adds to 180 degrees. And so, angles in a triangle add to 180 degrees. Now, the fancy thing here is that when I say that, it's implicitly implied that we're talking about the angles inside of the triangle. Not any angles outside, but the angles inside. And so we're going to add a vocabulary word here, and we're going to say specifically the interior angles. The angles inside of the triangle add to 180 degrees. Now, that's the what, but now let me show you why that works. Why is it that when we take a triangle, that angle A, B, and C all add up to 180 degrees? Well, the fun thing and the reason why is because of parallel lines. So let's go ahead and take a look at this example and really dive into the why it works. So first, we're going to start off with a pair of parallel lines. So here is our parallel lines. I'm going to draw a transversal like we've seen in the past, but now I'm going to be adding in another transversal. And if you haven't already guessed, this transversal completes our triangle within our parallel lines. So let's put all the pieces together here. What we know based off of this diagram is that we have a pair of straight lines, we have a transversal, and then we have a second transversal. So let's start labeling some things and start working from there. We care about the triangle, so we're going to go ahead and call this A, B, and C. Remember, our goal is that we're showing why all three angles within a triangle add up to 180 degrees. So that is why we're looking at this diagram and why I labeled the angles first within the triangle. Those are the three angles inside of the triangle, the interior angles. So let's start using our angle relationships, and we'll start building the diagram and looking at it from there. From A, B, and C, the reason why they add up to 180 degrees is because of our angle relationships. The one that I want you to pay attention to first here is the angle that's alternate interior from A. Focus on the fact that this is the transversal that A is on. Since that's the transversal, I don't need any sticky keys. No, thank you. Since that's the transversal that A is on, its alternate interior angle is going to be the angle inside of our parallel lines, and on the opposite side of the angle here. And so, what angle is that? It's this one up here. And alternate interior angles are congruent. So this alternate interior angle is the same size as A. So I'm going to go ahead and mark that as A as well. Now, let's do the same thing with C. And let's also look at its alternate interior angle. So from C, C's transversal is here, highlighted in blue. Its alternate interior angle in between the parallel lines and on the opposite side of the transversal means that this is where its alternate interior angle is, which is congruent. And so notice that A, B, and C all make a straight line. When we look at the fact that A and C are adjacent angles, remember adjacent means next to. A and C are adjacent to B, and they're all on this straight line, but they're not just on the straight line, but they actually make the straight line. From A to B to C, they all add up to 180 degrees because they're all linear pairs. They're all supplementary together. So, because of the fact that we have alternate interior angles on a straight line from our transversals, A and C added up with B equals 180 degrees. I'll say that one more time. Because alternate interior angles are congruent, triangles add up to 180 degrees. Isn't that cool? Because of our alternate interior angles, we know that a triangle adds up to 180 degrees. So that's the what and the why. The what is our triangle sum theorem. Angles add up to 180 degrees. Why? Because of our angle relationships. I look forward to seeing you in the next video where I go ahead and show some examples of this in action.